download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about current and circuit symbols. Now we use circuit symbols to show different components, i.e. parts, of an electrical circuit. Circuit diagrams are drawn in pencil and a ruler used to draw the connecting wires. For a circuit to work, it needs to be complete. And we will look at that in a future video. But for now, we're going to focus on these circuit symbols. And I think what would be a good idea is if you try and pause the video now to try and work out as many as you can first, and then we'll go through the answers. So pause the video now. Okay, so let's go through them. So this first one here, and when I tell that I'm talking about this one here, this is an open switch. Okay, so this symbol here represents an open switch, and therefore this one here represents a closed switch. This symbol here is a cell, and this is a battery. This symbol here represents a diode, and we'll talk about what all these are in a future video. This symbol here is a resistor, and this symbol here is a variable resistor. This symbol here represents an LED. This symbol here is a bulb or a filament lamp. This symbol here is a fuse. Here we have a voltmeter. And here we have an ammeter. Here we have a thermistor. And finally we have an LDR here, light dependent resistor. Now it's a really good idea to practice these symbols and constantly retrieve your memory on them. So keep testing yourself until you get all of them correct. Okay, so it might be a good idea to screenshot the answers here and then to cover and to test yourself, or you can learn them in whatever which way you want. Now before we get on to talking about electricity, we need to learn a couple of key words, and the first of which is charge. So by charge, we mean that negatively charged electrons are given a force by a battery and move throughout a circuit. Charge has a unit of coulombs. Okay, now just to give you a bit of a context on what we mean by a coulomb, an electron has a charge of about minus 1.6 times 10 to the power of 19. That's the charge of one electron, so it's very, very, very small. Okay, that therefore means that in 1 coulomb there is about 6.25 times 10 to the power of 18 electrons. Okay, so just to give you a bit of maybe something you can visualize, but maybe not because it's a very large number, and when we're talking about 1 coulomb, we're talking about 6.25 times 10 to the power of 18 electrons. Now a current is the rate of flow of charge, i.e. how much charge is flowing every second past a particular point. And its units are the amp or the ampere, and it can be measured with an ammeter. The ammeter measures the number of charges that flow through it in 1 second. Okay, so here we've looked at charge and its unit is a coulomb, and 1 coulomb is 6.25 times 10 to the power of 18 electrons. And current is the rate of flow of charge, and it's measured in amps. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. Therefore, we can say that charge, current and time are linked by this equation, where Q stands for charge, and we said that the unit was the coulomb, where I is the current, and it's measured in the amp, and T is time, and its unit, as ever, is the second. Okay, so therefore charge is equal to current times time. So charge is equal to current times time, and we do need to remember this equation. So let's go through a worked example and put this equation into practice. Calculate the current when 4 coulombs of charge pass a point in 8 seconds. So as we always do, first we need to write our equation that we've learnt. Okay, so charge is equal to current times time. Okay, however, this equation is asking us to work out current. So we need to be able to rearrange this equation. Okay, so it's time over here as the times. Therefore, to move it to the other side, we divide. So charge over time is equal to current. So this is the equation that we're going to use. Then what we're going to do is we're going to find the values that we know. So our charge is 4 coulombs. So charge is equal to 4 coulombs. And our time is equal to 8 seconds. And then what we can do is we're going to put this in our equation. So current is equal to charge, which is 4, divided by time, which is 8. Therefore, current is equal to 0.5 amps. Remember the unit is amps. What I'd now like you to do is have a go at answering these questions here, and then we'll go through the answers together. So pause the video now. Okay, let's go through the answers then. So first of all, draw the symbols for a bulb, cell, battery and voltmeter. Well, here's a symbol for a bulb, here the cell, here the battery and here the voltmeter. Okay, so they're the 4 symbols that I asked you to draw. Question 2, how much current must there be in a circuit if 1000 coulombs flow past a point in a circuit in 4 minutes? Okay, the important thing here is obviously to convert our minutes into seconds. So there are 60 seconds in a minute, so 4 times 60, you would have got 240 seconds. Okay, and then you would have done your charge over time, so 1000 divided by 240, and you would have got 4.17 amps. Question 3, a circuit is switched on for half a minute and 90 coulombs of charge flowed. What was the current flowing through the circuit? Okay, well again we have to convert our time. So half a minute is 30 seconds. Okay, then we can use that to do our charge over time. So 90 divided by 30, and you would have got your answer as 3 amps. Okay, so charge over time, you would have got your answer as 3 amps. Question 4, if there is a current of 10 milliamps in a circuit for 0.5 seconds, what quantity of electric current flows in through the circuit? Well, you first have to obviously convert your milliamps to amps, and to do that you divide it by 1000. So 10 divided by 1000 would have got you 0.01 amps. Okay, 0.01 amps, and then you would have times that by the time. So your current times time to get your charge, and it would have been 0.005 coulombs. Okay, if you got that wrong, maybe you just didn't convert your units. And finally, question 4, how much time is required for 0.3 coulombs of charge to flow past a point if the rate of current is 2 milliamps? Again, we need to convert our 2 milliamps into amps. So 2 divided by 1000 would have got you 0.002. Okay, then you would have done your charge, which is 0.3 divided by your current, which is 0.002, and you would have got your answer at 150 seconds. So we've now looked at circuit symbols, and I've shown you what the circuit symbols you need to learn are, and then we've looked at charge and current and how we link these together in an equation with time. You can now move on to the quiz and practice exam questions to really embed your knowledge, and if there's anything you need help with, then please get into contact with one of our tutors who will be happy to help.